Thanks a lot for inviting me and also giving me quite a hype, I would say, sir, about me. And I would extend my special thanks to Shiv Salam, sir, for making me come over here. I'm aware that this session is about standards, but I had taken a liberty and requested that I would touch upon IoT and IET in governance aspects, and what government would expect from industry, so that we would be able to serve the society better and take things forward. Now, Government of India had come up with IoT policy, wherein we try to provide an enabling environment so that we would be able to introduce IoT, and also IET goes along with it, in converting the processes into smart processes, which are driven by digital systems. So the approach of digital first was adopted, and now smart cities have tried to give actionable programs to that policy. But much before, the government has also started making use of IoT technology in many of its governance projects. So though the area is quite vast, I would not be able to touch upon most of it, but I would just touch upon the areas wherein I have actually been associated with. So one such sector is the transportation sector, where I worked as managing director in Bangalore Metropolitan Transport Corporation. It's a bus transport company. Now, when I landed there, then I realized that we need so much of computing to run the public transportation company, which will give benefits to the citizens in terms of responsive, reliable transportation service, which is at the same time has to be an affordable service. Now, if you look at the kind of areas in which IoT or IET can play a role is phenomenal. By the time I landed there, something called as intelligent transportation system was introduced, and the data which was being generated by ITS system was per day 30 GB data was getting generated. So the guys in BMTC were clueless as to what to do with this data. They would even not be able to save it, forget about making use of it, analyzing it, and then bringing value into the business of BMTC is beyond the realm of the officers who were there. And then we could get help from organizations like Deloitte, IFC, and also WRI. WRI guys came in with quite a number of experts, and they could come and help us with analyzing big data and then trying to make use of that data for our scheduled rationalization. I'll not go into that aspect in detail, but then I'll just touch upon the areas where we try to introduce some kind of systems where we would be able to generate data and then try to improve our efficiency. For example, 6,000 to 7,000 buses are run in a day in Bangalore, and of which, when I landed there, about 200 buses would not come back to the depot. They will be on the roads. And then the police will be going there with full equipments to remove them from the road and then making the traffic flow regularly. So we tried our level best to bring it down. So by the time I was about 1 year old in that organization, I could bring down from the 200 to about 20 per day. But then that involved a kind of orthodox method wherein every day you keep your mechanics, your managers on the toes, and then ask them to check every bus, the moving part of the bus to be checked before the bus is sent out, which is a Herculean task when you have fleet of about 7,000 buses. So that is when we started talking to the manufacturers and then trying to find out, can we come out with some sensors in each of the moving items, if not each of the moving items, because IC engine based buses versus electric buses, there is huge difference, but we had only IC engine based buses in which about 350 to 400 moving parts are there. Every moving part is likely to undergo some kind of wear and tear and give up. Once it gives up, the bus can get stranded on the road, and then it can Now every day we need to get data on what kind of maintenance activities will have to be done. When the bus comes back to the depot, we need to look at what has to be checked up, because all 340 moving parts cannot be checked every day for a bus. So we need to have a system wherein we need to make our conductors, drivers, and even we try to reach out to the citizens also to tell us about what is, what's the noise they heard, or what is the, level of jerk they experienced, and that kind of data we were trying to collect. And then getting the data to the mechanics from the passengers, from the conductors, from the drivers, and then try to take it into the mechanics, make them analyze the breakdowns and the failures, and try to come out with root cause analysis. So this is how we were trying to work out. Then we started working with the companies, Ashok Leyland, Tata, and Volvo. Each of them will not talk to each other, other parts. Sir was talking about standards. Now, if the standards actually run contrary to the business interest of the companies who come up with solutions. So they would like to protect their paradigm so that their revenues always goes up and our dependency on them is higher. So we were talking to them and trying to find out, can I go for a predictive maintenance approach, wherein if the lifetime of a moving part is approaching the end of life, then I should be able to get an alert. Then I should give a system which enables our mechanics and the managers at the depot to change those parts so that I don't end up losing the business for the day. So this, when we try to do, every bus manufacturer will have their own standards. So I would not be able to procure sensors which is common for our entire fleet. So every time I need to talk to 3 different people, and if I have to get the data, OPC based standards are not there, so I will have to devise PLC for each device and then get the data and process them. So it's a Herculean task. So now, in case if industry can work on and startups can work on, come up with the low cost devices which can actually get the data from each moving part and then make it available for the IT system, then probably the maintenance will be better. If the maintenance is better, our reliability of the service will be better. And if the reliability of the service is better, then throughput will be higher. When the throughput is higher, the service is reliable for the citizens as well as the cost will come down. Then the tariff which we charge to the citizens can substantially come down. Similarly, if we talk about the fuel management, again the fuel management, from getting the fuel from the refineries to the depot, measuring each of the quantity which is delivered to the depot bunk, and then fueling to the buses. Now, if all this can be through RFID tag, it can be automated, and then we get the data, we would be able to measure which bus has done how much mileage per liter of fuel which is done. Now, the mileage depends on two things. One, mechanical or the performance of the instrument, as well as the driving behavior. If the driving behavior is bad, then the fuel consumption could be higher. So now for me to bifurcate these two, should I focus on the driving behavior, or should I focus on the condition of the bus? This itself I need data. And if this data can come to the management, we would be able to at least reduce our bus tariff by about 20% straight away. So this is the extent to which IoT devices can actually help in fuel management. Then vehicle tracking system, you all know that vehicle tracking system, if it is done, it can actually result in multimodal integration between metro and the BMTC. We would be able to connect each other and then give a better user experience for the citizens. Today, we are all talking about traffic problem in Bangalore. If at all traffic problem in Bangalore has to be handled, it has to be through public transportation system. That public transportation system, if it is efficient, if it is able to give a holistic solution to the mobility needs of the citizens, probably citizens will try to reduce their dependency on the private vehicles and would switch over to the public transportation system. So for which we need to have a better vehicle tracking system to be installed in each of the buses which are moving in the city, and get them connected to the metro, and then provide a holistic mobility solution to the citizens. This also will require a lot of IoT devices to be provided in the buses, as well as getting the data to analyze and then put it on the public domain, as well as to the customized PA system, so that we would be able to communicate to the citizens and then make them plan their mobility from one location to the other location. So another important aspect apart from the public information system which can be built is that passenger counting system. Passenger counting system. Today, if you look at the tariff in the BMTC, it has fuel as a major component, and then maintenance another component, then the staff component. Now, if we have a passenger counting system, automatic passenger counting system, which will be video camera continuously running in the bus, and then detecting number of people entering in and then exiting out, and then if that can give us data, it can be analyzed using the edge computing system, then we will be able to get the data. Then we can straight away take off the conductor from the bus. If I am able to do a conductorless operation of the buses, straight away the tariff can come down by another 28%. If I am able to reduce the tariff by 50%, probably the footfalls in the public transportation system can go up by 3 to 4 times. So that's the extent to which the IoT devices can help us. And similarly, now this gets the service provider now gets linked to the traffic management. If I am able to run more buses and reduce reduce cars, then the traffic also becomes better. Now, in managing the traffic, you all know that ITS system for the traffic management, which will have queue management system, adaptive signaling system, variable messaging system, all these things can be leveraged by going in for on-board devices and off-board devices, on-road devices. If these can give us data, this data can be put into navigation applications. So navigation applications can give the information to the citizen, so that citizens would be able to better avoid congested roads, as well as further planning for demand side management and supply side management can be enabled. Demand side managements like congestion tax and carpooling system, multimodal integration can all be achieved if we are able to achieve this data generation from the devices which are placed on road as well as off road. Now, Directorate of Urban Land Transport, in which I was commissioner for some time, it has already instituted a project called as ITS for the city. Probably it will now get into a piloting stage in another 6 months' time. If that comes, given the infrastructure, road infrastructure in Bangalore, how do we improve the mobility by going in for technology? That is the project which is being funded by JICA and Government of India. Hopefully that will address more on demand side management rather than supply side management. Whenever we talk about the traffic, we always will say that we need to build more roads and widen more roads and bring in more flyovers and that kind of stuff. That is one side of the story. The other side of the story is demand side management. So demand side management will probably get addressed in that ITS system which is going to be piloted in Bangalore. And hopefully it brings some relief to the citizens of Bangalore. Now when I talk about supply side management of the traffic management, again it gets linked to the urban planning, of which I was partly very briefly associated with it. But then now if you look at I'm sure most of you would have passed through the Hebal flyover. When you have to cross through Hebal flyover or Tin Factory side or Silk Road, it's a nightmare. You need to be prepared that it can take about 5 minutes or it could take about 15 minutes also to cross. So now, why is this happening? This is happening because urban planning is being done in a conventional way, wherein we absolutely don't use any past data. Whatever data we use is only the static data which is available with various land records departments and then the municipal corporations. But then what is needed is that if you have to do a urban planning, that urban planning will have to plan for the circulation pattern. Now the circulation plan will essentially depend upon what is your population density, which is directly proportional to the FSI or FAR you have allowed in a particular area. Now, if I have to plan for this city, which has to grow vertically and meet the aspirations of the economic aspirations of the city and its citizens, it will have to be efficient. So, for that, city has to grow vertically. The moment you start growing vertically, then the infrastructure experiences stress. Now, to what extent I can actually allow the vertical growth without causing too much stress on the infrastructure. So, infrastructure, road infrastructure, water supply infrastructure, the sewerage system, and all of them together. Now, how do we decide this? To what extent I can allow this FSI to be allowed in this? For that, you need to have a data. Main data which actually goes into this is in preparation of the master plan for the cities is that traffic and transportation study. Now, if you look at the way traffic and transportation study is done for over a period of 2 months, in major junctions you put up counting booths, and then you go on counting the vehicles which are crossing. But what we need is, where does the traffic originate, where does it destined to? Based on this, you would be able to plan in such a way that where should I reduce the FSI, where should I divert the traffic, where should I build more supply side management, and where do I introduce demand side interventions. All these things will depend upon the data which will come from traffic and transportation study. But now that study is about 100 years old method. Now, how do we transform that? Now, supposing that we get the data of mobility using the telecom sectors, the non-personalized data, if it can be taken, or the navigation companies which have come in a big way, they can share the data. Then if we do, then we will get a dynamic OD matrix data on regular basis. So this can actually help the planners in urban sector to go in for a better supply side management coupled with demand side management. We would be able to build better cities which cause lesser traffic snarls, and then help you move better and cities can grow better. So these are the things which I thought would talk about as far as IoT and IET. I know the technologies in governance is concerned. It's a kind of view of one or two sectors, and the potential is unlimited. Before I came here, I just went to the stall where I looked at Sarthi system being built by this organization. I'm quite happy that they are trying to do something which Switzerland sir said that it is not meant for making money, and it doesn't make as a economic viable project. But then I was looking at from the project that it can help people, it can help government. It's a project which is being taken up for helping citizens as well as the government to handle the epidemics which are lurking around. So I'm sure that project will grow better and will serve citizens and government also better, and I would also like to get associated with it. Thank you for giving me this opportunity.